Today we're going to talk about the law of sines, section 8.5.1. We're breaking up section 8.5 into 2 days. We're going to talk about the law of sines strictly today. Okay, so law of sines, section 8.5.1. You can use a calculator to find trigonometric ratios for obtuse angles. So for instance, obtuse angles is anything greater than 90 degrees. So if you type in your calculator, there's sine of 115, you get approximately 0.906. Cosine of 270 is 0. Tangent of 960 is negative 9.514. And you can go on and on and on. The law of sines is used as ratios. For instance, for any triangle ABC with side lengths A, B, and C that are opposite of angles A, B, and C, notice big A is opposite of little a. Big B is opposite of little b. And big C is opposite of little c. Okay? You can set up, what do these look like? They look like proportions, exactly. You can set up proportions or ratios, and they are equivalent. So the sine of angle A over the side of A is equivalent to the sine of B over B, and the sine of C over C, and so forth. Okay, so what that means here is you can take non-right triangles and solve for missing angles and sides using the law of sines. Okay, so here they set up the sine of P over MN equals sine of N over PM. So angle N is opposite of 7. Angle P is opposite of 10. So I take the sine of P over 10 equals the sine of 36 over 7. And then from there it's just cross products. Okay, so you take cross products, cross multiply, and divide. Now remember, anytime I am finding degrees, I have to make sure I use the inverse button. Anytime I'm finding degrees, I have to make sure I find the inverse button. If I'm finding side lengths, it's a lot easier. Remember, degrees, I have to use that inverse button. Alright, so that's what we're doing today. We're using proportions and the law of sines to solve for non-right triangles. So number 1, 2, and 3 here. Use a calculator to find each trigonometric ratio. Round to the nearest hundredth. Take a couple seconds to try these 3. Number 1. Use a calculator to find each trigonometric ratio. Round to the nearest hundredth. What do you get for number 1, Drew? Negative 0.9 what? So 9.
No, negative 0.24.
Negative 0.24. I was going to say what? I think you said 9. Negative 0.24. Thank you. Number 2, tangent of 225. What do you have for the tangent of 225, KZ? It is 1. Nice job. And number 3, the sine of 100 is what, Max?
0.9.
Very good. What did you notice was different about this problem? You had a negative. Okay, when it's over 90 degrees, essentially, you can get negative ones there. Okay. So let's use this information and the law of sines to solve for the missing side lengths and angles. Find each measure, round the length to the nearest tenth. So length to the nearest tenth, and the angle measure to the nearest degree. Alright, so number 4. Remember, law of sines is the sine of A over A equals the sine of B over B. Again, sine of an angle over the opposite side is equal to the sine of another angle over the opposite side. So, who thinks they can set this up correctly for me? Camden, what are you thinking, sir?
Sine 64 over
X. We'll call that X. Nice.
and sine of 41 over
Nice job, sir. Yep, sine of 64, because we're going opposite, equals the sine of 41 over 18. So now when I do this, I want to try and be precise. Don't try and round early because you're going to get some different answers. Again, we're doing this, try and make kind of more precise answers. So I'm going to take the sine of 64 times 18. So sine of 64 times 18. Then I'm going to take that number divided by the sine of 41 because we're just using cross products here. So sine of 64 times 18 divided by the sine of 41. Now I'm going to get a side length here. And that side length is going to come out to be approximately what, Caitlin?
Wait. Times What?
Equals. There you go.
24 points. What do we round it to?
To the nearest tenth.
7.
So I get approximately 24.7. Nice job. Meters. If I might symbol it. Okay, nice job. And again, the more decimals you include in there, the more precise your answer is going to be. Nice job. Number 5. I want to set up another ratio. How can I set that one up? Troy, what are you thinking, sir?
X over 26 equals sine of 2 over 40.
Nice job, sir. Now, what am I trying to find here, Troy? I'm trying to find the what? Angle measure. So what trig function do I have to do at the very end, Troy? When I'm trying to find angle measures, I have to do what trig function? The inverse function. Nice job. So I would take the sine of 102 times 26. So I get 42 equals 26 times the sine of 102. So 26 times the sine of 102, or 42x I should say, divided by 42, and that should get you a decimal. You will have to take that decimal to the sine inverse, or sine inverse of that decimal. Okay? And if you have to, you might have to write down that decimal. For example,
All of them down, or is the first 5 good?
first 5 are probably pretty good. First 4 for sure is usually pretty good. But when I do that, I get what is a decimal here?
That's not it.
Don't you end up with like what is it?
60, 55, 1.
0.6055.
I think so.
Okay, so now I have to do the sine inverse of that. Sine inverse of 0.60551. And I get degrees as approximately what, Peyton?
37.
37 degrees. Now remember, we talked about this a couple of chapters ago. But in relationship to triangles, the shorter angle is always opposite the shorter side. The bigger angle is opposite the bigger side. So would it make sense if I had an angle that was bigger than 102?
Nope.
No. We realized right away it should be smaller. Okay. All right, take a couple seconds to try these two. Using the law of sines, set up the ratios that are kind of set up for you already, and solve for the missing angles or side lengths. All right, let's start walking through this here. So number 6, how would you set up number 6 using proportions? Jack, how would you set that up? So the sine of 109 over 20, John McQuite, equals? Nice job. So sine of 109 over 20 equals the sine of 47 over x. And then I use cross products and I solve that. And I get an answer of what, Jack? 15.6. Or 47 or 57?
What if you round it? 7.
So 15.5, so it said round to the nearest tenth.
What if you round it really low?
Then you might have a slightly off decimal, and that's okay. If you're within a couple decimals, you're usually pretty good.
It's Jack Milady.
Number 7. I want to set up a proportion ratio here. Boger, how would you set this one up, sir?
You do 70 over
Sine of 70 over
6.2 centimeters
equals?
x
Okay.
over 3.5.
Nice job. And you're going to have to get a decimal here at the end. Your decimal, what do you have to do with that then? Noah, you have to use the inverse button, right? So I take sine of 70 times 3.5 divided by 6.2. And then you get a decimal. What's that decimal come out to be? Yeah. Who remembers what the decimal comes out to be? Not the answer. 0.5307? 047. And then I do the sine inverse of that. Sine inverse of 0.53047 gets me an answer. That is what, Trevor?
32.03.
Approximately 32 degrees. Again, remember, when I'm finding degrees or angles, I have to make sure I use that sine inverse button. All right, take up seconds, try numbers 8 and 9. Same idea. Set up proportions or ratios and solve for them. Number 8. How would you set up the ratio for number 8? Camden, how'd you set it up?
Well, I did the sine of 34 over 7, the sine of 34 over x, and the sine of 34 equaled 0.5591929.
0.55 what?
9, 1.
Okay, great. Go to sine of 39.
Yeah, and then the sine of 39.
Okay, that's all right. Then you use cross products, right?
Yeah,
And you solve, and you got EF comes out to be what?
7.9.
Approximately 7.9. Nice work, sir. Again, angle, opposite side. Angle, opposite side. What about number 9? What do you get for angle N to come out and be? Ryan, set up the proportion first.
I did sine over 50, or sine of 50 over 7 equals sine of n over 5. And then I got like, when I did all the math, I got like 0.54717.
Okay, and you have to do the inverse of that, and then angle N comes out to be
33.
approximately 33 degrees. Nice job. That is correct. Again, remember, law of sines is just ratios, opposite angle or opposite side. Here is your assignment.